Again, welcome everyone. Let me share my desktop and go over the plan for the day. Okay, you should be able to see the desktop. And let me tell you the plan. And pretty much always going to start out with number one, which is Q&A. And that is any questions you might have. We're just at the beginning of the class, so you may have questions about the class. I'll be happy to answer them. And then after that, we'll get into, sorry, I'm not sure what I could do about the sound issue. Let me see, let me click this. That's not it. Maybe turn my volume up or something if it even allows me. Not a lot I can do, that's a problem. Submit. Audio settings. Microphone. Let me put my volume up and see if that helps. Oh, man. There we go. There's also some background noise too that sounds awful. Let me ask, does that help? No? Okay, one more try. How about, does that sound better? Did it suppress background noise at all, no? Okay, there's a lot of options there. Go back to auto. Yeah, sorry. Sorry, I don't have COVID or anything, it's not my throat. Yeah, it could be the mic, it could be internet. My mic hasn't changed, and it used to be up fine, and I haven't done anything to it, so my guess is there's internet problems because we are having bad weather here. So sorry about that, because that happens with that voice thing. One possibility, let me try something. One more try. I'm going to try to stop my own video. And let me ask you, does that help the sound? Can you hear better now? Can you hear better now? Okay, that didn't do it. Okay, I think I'm running out and I want to get to the class. Sorry. I apologize. I've tried everything I know how to do. I know a lot, but can't do it all. Let me go back to the video then since that wasn't the problem. Okay, so sorry about that. If you can't hear me, either say something or pop in the chat box that you can't hear me. That just so you don't understand. And I apologize that not much I can do at this point. So I will answer questions if you have them. We'll get into sampling techniques. And that is actually really important. Really, real life is really hard. It's not that hard in terms of this class, but in real life, coming up with a good sampling technique for a good study is very difficult. But in this class, it's just a vocabulary of it. Then, I know this sounds funny because it's the name of the class, but we'll talk about statistics. And those are things like the mean, the standard deviation, the median, all kinds of things. We'll look at a few charts. Okay. And then we'll do a z-score. And we'll talk about some variables. So that is the plan. So let me ask you any questions about anything. Any questions? Okay, if there's no questions, then I want to talk about sampling techniques, and I like to do it by kind of doing an example. Let me go to one of our big newspapers, and that's the Tahoe Daily Tribune. And what I like about this one is that if I scroll down a bunch, they always have a survey. And here's a survey. That's how a lot of you live, and you could have issues too, probably not as much as we do, but are you ready for wildfire emergency evacuation? And the choices are, go bags are packed, yard is raked, and I've signed up for emergency notifications. The next is, after last year, I'm always in a state of preparedness. And the third is, not yet, I'm enjoying the clear, smokeless skies. And then finally, I'm exhausted with drought, and the threat of wildfire, thinking about moving out of the area. So I wanted to ask you a couple things. One, tell me which one you would pick for you personally. Put in the chat box. And I want to remind you that the chat box is not recorded. So it is it's private on YouTube, at least. You guys can see each other, but that's okay. So put in the chat box which of the four you would call yourself. Let's see if all of you can put some in. All right. Give you a moment. It shouldn't take long to type it in. And you can do 1, 2, 3, 4 as I type in. Okay, looks like 3 is the one. Not yet enjoying the clear smoke with guys. So that's kind of what it is. I think I'm on number 2. After last year, I'm in a state of preparedness. Okay. There's a couple of the others are too. But I'm gonna vote number 3. I'm gonna vote. And it's gonna give you answers. Oh yeah, I already voted, so I have to, let's try this. It's the problem with teaching this class twice. One more try. So I can view the results. Okay, so what we see is the results. And I want to look at a few things. The first is, if you look at the answers, that are possible, it's a bunch of words, okay? After last year, I'm always in a state of preparedness, okay? It's a bunch of words, okay? And it's still a survey, but when you have a survey where the answer are words, then what we do is we say the variable is qualitative. So let me type that in. So we typed variables, and one is qualitative, and that means words, word answers. One special case of qualitative that happens a lot is the yes/no question, and that's still a word answer. You know, if I ask you something like, do you live in Tahoe? You're going to say yes or no. Okay, so it's still a word. You're not going to say 37. On the other hand, if it's a number answer, it would be quantitative. That means number answers. Okay, and that's important when we're breaking it up into these types, okay, throughout the entire course. So we want to get this down. And it turns out there's different types even within these, but I want to, these touch on the main points. Any questions on that? Any questions? Okay, we can also look, it says total votes are 235. 235 is called our sample size. So let's put that in. The letter we use for sample size is N for number. Okay, any questions on that? Okay, so one of the questions I might have for y'all is, when you look at the answers, do you think this is what Tahoe is? Does this represent the people of Tahoe? Or is this biased? So you think there's a good chance, it's probably likely that pretty close to 17% of all Tahoe people have go bags packed, yard raked, and signed up for emergency notifications. Okay, so this is biased. Okay, so this is an example of what's called a convenience sample. All they did is they post something online, whoever read it and felt like answering answered. Those who didn't feel like answering didn't. And This is total convenience sampling. They didn't do anything to make sure that the answers are representative of the Tahoe people. Any questions on that? So let me type something in. That is survey. So convenience sampling means survey, whatever is easiest. Just go to post online and you hope for a bunch of answers. Okay. Do you think a convenience sample is trustworthy? What do you think? Yeah, it's usually not very trustworthy. Okay, so you should always be skeptical about. So then comes the harder question. Okay, how could they have done better? Could they have gotten the answers from every person in Tahoe? There's something like 23,000 people, residents of Lake Tahoe. Could they have gotten everyone? What do you think? Any thoughts? Yeah, the answer is not a chance, okay? We do have a large population, and probably not even that large, but getting everyone is pretty impossible, okay? If you get everyone, you call it a census. You've probably heard of it, the census is actually in our Constitution. So if you get everyone, that means you have a census, and with a large population, it's just not even possible. Okay, imagine trying to do a survey about, I don't know, average height of people on Earth. And if you tried to get everyone, it's never going to happen. You're never going to be able to survey every person on Earth to find out how tall they are. Is that fair? So this class is all about handling and dealing with that, the fact that we can't survey everyone. So what we're going to be doing is we're going to be taking a sample. Okay, in their case, they took a sample of 235. You know, out of the 23,000 or so Tahoe residents, so 1 out of 100 people answered this survey, something like that. So you almost never even get a large proportion, which is fine if you do it right. So then the question is, if you want to get a sample, and you want your sample to be representative of the population, any suggestions on strategies to do that? Any thoughts on how would you get a sample that would be trustworthy? Any ideas? You can say no, that's fine too. I just want to make sure you're listening. Survey a sample population representative of the general population of the area. Sounds great. How do you do that? How do you get a sample that's representative? And by the way, I just want to mention, don't say it's sample population, it's just a sample. So there's the population, which is everyone, and the sample, which is a portion of them. You don't want to put those words together. Okay, so I want to talk about a few ways. It's hard, and that's why you're taking this class, so that you can learn different ways of doing it. One is identify areas where it might make a difference in terms of how people answer this question. So for example, maybe age. You know, old people might have different preparedness than young people, for example. I don't know for sure, but that might be true. Does that make sense? So in that case, what you would do is you would research the age brackets of people, the percentage of each age bracket of people in town. And that's something you could probably find. You know, you can probably get it somewhere online and find out how many people are there that are under 18, how many people that are between 18 and 25, how many between 25 and 50, and how many 50 and up, or something like that. And what you can do is you can say, what are the proportions of each of those groups? Then what you can do, if you want a sample size of 235, is you multiply 235 by that proportion, say the proportion of 18 to 25-year-olds, and let's say that proportion was 30%, then you say 30% of 235 is I don't know, 72 or so. And then you make sure that in your survey, you have 72 people between 18 and 25. And then you do the same for each bracket that you're looking at. Any questions on that idea? Okay, and what that does, it avoids the bias of how old people are. Okay? So if it's all old people or all young people answering the question, you're going to have bias. So let me write out what that is. That's called stratified sampling. And that's step by step. One, identify the strata which breaks the population into groups. Okay, so your strata might be your age groups. It might be gender, male, female, and decline of state. It could be political affiliation, Republican, Democrat, and other. Okay, there's lots of strata you can do. Okay, that's step one. Step two, research the percent of each group. Okay, that usually means get online and find out what percent of each group there are. Step three is multiply the percents by your sample size. To establish quotas. So if there's any questions on any of these steps, let me know. This is very important. Okay, and then the final step is survey to ensure that you ask exactly quota amounts. So if your quota was, 72 people between 20 and 25, then make sure that you ask exactly 72 people between 20 and 25 years old. Any questions on that? Okay, and what this does is it avoids bias of certain categories. So in my example, it avoids age bias. Any questions on that idea? Make sense? Okay, so that's one kind of sampling. There's a lot of kinds of sampling. We've seen convenience sampling that's easy to talk about. Let me do another one that is usually impossible. And it's one that you've heard of before. Random sampling. How do you get a random sample? In a way, that's the very best you could do is a random sample. But how did you get a random sample of people in Tahoe? Any thoughts? Any ideas? Or if you have no idea, that's fine too. Government mandated survey sent to random residents. Okay. And you must take a survey. Okay. So that sounds great. And here's the big problem. It's against the law. A survey like this, you are not allowed to mandate a survey like that. You are not allowed to shoot people if they don't take the survey. So this is what I'm saying. Random sampling is usually impossible. So especially people in a town or in a country or something like that. So you usually can't do perfect random sampling. And when you read an article and it says they did random sampling, they're usually lying. They don't understand it. And that happens a lot, by the way. I've noticed that. Hopefully, when you finish taking the class, you'll be a lot more aware of the issues with all kinds of stuff. Does that make sense? So random sampling is wonderful if you can do it. Here's when you can do random sampling. So let me give you an example. And this is a different article. It's a really cool one. I read this one. It's a really fun one. We'll talk about this in a bit. And that is a new genetically modified purple tomato may hit the U.S. grocery store stands next year. Okay. What do you think? Do you trust it? Okay, you don't trust it. Okay. So in order to trust it, what would they have to do, or what would the FDA have to do? And that's something you want to think about. And the first thing you do, here's what you don't do first thing. You don't genetically modify the purple tomato to be purple and then give it to a bunch of people and say, eat it, you might die, but you don't test it. Right? They don't do that. What do they do instead? Your thoughts? See, I'll jump in. And I tell you, you'll say, of course. I'm trying to think there's in here somewhere that talked about it. Still not finding it right away, but you can trust me. I read the article. I'm trying to remember exactly where it was in the article. And speed reading. There we go. Okay, the results were stunning, she said. Cancer-prone mice that ate the purple tomatoes lived around 30% longer than those that ate normal tomatoes. Okay, according to the study. So all of a sudden, you say that I wouldn't eat that tomato, but when you see this, it's like, well, what if it helps stop cancer? And it turns out with mice, you can do a random study. So what you might do, and I actually have a niece that does this for a living, if she works with mice studies, is they take a whole bunch of mice, let's say they take 200 mice, and they number the mice from 1 to 200, and then they randomly pick 100 of the mice. Okay, and that you can easily do using a computer. You can ask a computer to, pick 100 random numbers from 1 to 200, and the computer will do that. And then the 100 mice that they pick, they feed them the purple tomatoes, and the 100 mice that weren't picked, they give them red tomatoes. And they do that for, I don't know how long mice live. I'm not a biologist, but let's say they do that for 6 months. They see how many of them got cancer, and they can compare and do a study, and they can find out what's happening. Any questions on that idea? Is that pretty cool? And what they found in this study, because that's what they did, I had about 200, I don't know the sample size, it doesn't say. I could read the study, but that's basically what happened, is they found out that the purple tomatoes had double the shelf life of the red cousins, and the mice were less likely to die of cancer, the ones that had the purple tomatoes instead of the red tomatoes. Is that pretty cool? Okay, and that is called a randomized control study. So they can randomly select half of the group, and then the other half doesn't get the purple tomatoes, and then they look at the difference between the two. Okay? Any questions on that? Okay, let me tell you another one. Did they do this on humans? Randomized control studies? What do you think? Okay. Do you think they do randomized control studies on humans for other things? And the answer is yes. Let me give you an example that's the most important example in the last couple years. What's the most important example of a study that was done in the last couple of years. Sorry if you can't hear. I'm not sure what I can do about it because again, it's a microphone issue, and I don't have another microphone. Yeah, the COVID vaccine efficiency. What they did is they had a sample size of 4,000 people. 20,000 of them, they gave them the vaccine. 20,000 of them, they pretended they gave the vaccine. You know, they gave them a shot of nothing. Yeah, I so apologize if it's hard to hear. I can't do anything about it. There is closed captioning. That might help. So I don't know if the closed captioning can hear me and can follow it. But that's one way you can turn on closed captioning. And that might make it easier to hear. And that then you can read what I'm saying. Okay. So they do a randomized control study, and they found out that those who were vaccinated were less likely, much less likely, to get COVID. Okay, so it worked. Sorry if closed caption doesn't help. I tried. I'm working on coming up with ideas. Yeah, unfortunately, I'm using this, but I don't have another microphone. So the next one, I'll talk to our computer services people and get one. I never had this happen before. Sorry. So it turns out that a randomized control study is great if you can do it. Okay? So those are very trustworthy. Let me tell you another example. Of a way that studying research is done and sample collection is done. And that's called cluster sampling. And that's really done in education, actually, in the college. So let's suppose we wanted to ask students a survey question. How about a quantitative question? Something like, I don't know, how many units are you taking? And let's say we're looking at Lake Tahoe Community College students, and we're going to ask them how many units are you taking? What they usually do with say, student surveys, and many others too, is they do what's called cluster sampling. And that means you break the population into many, many clusters. Pick a few of the representative clusters. So by the way, I'm trying to type what I'm saying, and that will help too, hopefully. Pick a few of the representative clusters, and then survey everyone in the picked clusters. So what is the typical cluster in college? What do you think? Major, good idea. It can happen, but not usually because it's pretty hard to ask everyone in a major. I don't see you answering, but the answer is no, classes. So you would pick, so that means you're going to pick representative classes. Such as a math class, math online class, maybe an English face-to-face class, maybe a soccer class, then survey every student in those 3 classes. And the idea is that you get a representative sample. There's no volunteer response bias. Okay, there's no volunteer response bias. And that's when, people who answer the question are more likely to say something than someone not answering the question. Any questions on cluster sampling? Okay, then the last one is systematic sampling. And this is especially done in manufacturing. Okay, so let me give you an example. For example, I helped with a study for a towel manufacturer. Okay, they picked 50 towels to look at how long they lasted. Okay, so now we're talking about a factory. So what we did, we grabbed every 100th towel that came off the assembly line and tested them. Any questions on that? So in general, systematic sampling involves selecting every nth item. That works when you can order things. Any questions? Any questions? Okay, so that's a few things. What I want to do now is I want to conduct a study of you. So let me ask you. You can say whatever you want. What are you interested in? So put it in the chat box a survey question. Okay, age. So here's the question. How old are you? Okay, please, everyone, give me your age or at least make something up. Okay, so what I'm going to do is now I'm going to go to the calculator. I'm going to go to one variable statistics calculator. It says type in the values from the data set separated by commas. For example, 2, 4, 5, 11, 12, and click calculate. So I'm going to do that. And I got to read all of your answers. 21, 18, 17. 28, 2018. 17. Okay, and we can think of you guys as a sample of statistics students. Totally a biased sample because it's just those who showed up. And so I'm going to hit sample standard deviation. Then click calculate. Any questions? Any questions about what I did? Okay, so the mean was 19.857. What's another word for mean? Yeah, average. So hopefully you all know what average means. I don't have to explain it. Okay, then the minimum, I hope you all know that, is 17. We also have Q1 is also 17. Okay, that's something you probably don't know what it is. Q1 means the first quartile. So that means that 25% of the sample is 17 years old or younger. Any questions on that? Okay, and this is, turns out this is an approximation. This is something that drives me crazy. There's no solid definition for first quartile. And I'm not going to get into details, but I can't believe that it's the only thing I know in math where, depending on who you talk to, you get a different definition of the math terminology. So sorry about that, but you can kind of think of it this way. Any questions? So that means since it's the minimum is 17, 25% are 17 years or younger, and that means 25% are 17 years old. Okay, approximately. With a big sample, it looks better. Okay, the median is 18. Who remembers median? Who remembers what that means? Yeah, it's a middle number. That's a middle numerical answer. Or the average of the two those. If there are an even, odd, let's see, yeah, even number of answers. even sample size. Okay. Let's read some more. Q3, it's 21. What that tells us is very similar to Q1, but instead of 25th percentile, it's a 75th percentile. So 75% of the sample is 21 years or younger. Any questions on that? Maximum is 28. I hope you all understand what that is. Standard deviation. Is 3.8914, and I'm going to increase the size. I'm going to boldface it, put it in red. Any guess on why? Yeah, this is the most important statistic of the course. Okay, so the standard deviation is 3.8914. So it's very important that you understand what the standard deviation means. So the standard deviation is kind of an average distance away from the mean. Okay, I'm running kind of, because mathematically it's not quite perfect, but kind of for a good feel, that's what you want to be thinking about. So it tells you how spread out the data is, or the data are. Data is plural, by the way, so it's an R. Tells us how spread out the data are. Okay, so in this case, the standard deviation is less than 4 years. So do we have a spread out age? Okay, so the question is, how do you calculate it? Did you all understand how I hit the button calculate? Okay, so in this class, you have to hit the button calculate. I'm going to say it very quickly. If I say it very quickly on the formula, that means you're not responsible. Standard deviation is 1 over n plus 1 times the square root of the summation from I equals 1 to n of x minus b quantity squared. Got it? Okay? If I say it fast, you're not responsible for having the formula memorized. But you are responsible for knowing how to hit the button calculate. That sound fair? Okay? And even more important, you're responsible for understanding it. So understanding that it tells us how spread out the data are. Okay? So let me give you, I mean, it's kind of cool to see that, you know, y'all are pretty close in age. That's what this says. 4 years is not that much different from each other. And by the way, if I answered this survey, we'd have a much bigger standard deviation. How come? It would increase the mean, but even more so, it would increase the spread, the range. Because I'm the old guy. Does that make sense? All right, so let me give you some applications of standard deviation. First is money. Of the mean earnings in stock per year is 12%. By the way, is that a good, what do you think? Does it look like a good investment? Right? Earnings mean the value of your stock. When you bring in your dividends and you bring in your increase in the value of the stock. Okay, so 12% sounds really good. Okay? On the other hand, we don't know yet. I have not given you enough information. So let me do a scenario with the same 12%. So suppose you invested your college funds into the stock, and the standard deviation is 30%. What's the issue? Any thoughts? Yeah, you have a wide variance return. That means there is a high risk of ending up losing money and not being able to afford college. And then you have to drop out. You see that? Any questions on that? Unsure what the 30% is. So that's a good question. So let me give you a good rule of thumb. And that is, and it's called the empirical rule. And it's the following. If the shape, and we'll get into this not this week, but just trust me on this, of the distribution is normal. And that's that shape. Then there's a 68% chance of being within one standard deviation of the mean. Okay, so in this case, if you take 12% and subtract 30%, if you do that subtraction, you get negative 0.18. And notice if you take 0.12, 12%, and you add 0.30, then that's equal to 0.42. Now, this is a math class, so you ready for math. So that means that there's a 68% chance that you're going to be somewhere between losing 18% of your investment and gaining 42%. So high risk. You might make a lot, you might lose a lot. Any questions on this idea? Okay, let me give you more. There is a 95% chance of being within 2 standard deviations of the mean. Notice that 2 standard deviations would be 60%. Right? 2 times 30% is 60%. Any questions on that? So similarly, if I subtract 60% from 12%, I get negative 0.48. And if I add 60% to 12%, I get 72%, or 0.72. Any questions on that? All right. And then finally, there is a 99.7% chance of being within 3 standard deviations. I'm not going to spend the time doing the full calculation on that, but any questions? Okay, so if you're investing, okay, if you're putting money into something where it's really bad, if you end up losing money, the standard deviation being high is terrible for you. On the other hand, and I do a lot of investing, by the way, when I invest in what I call play money, which means that if I lose the money, there's really no terrible effect for me. It's not like I'm going to have to drop out of school or lose my health care or, lose my house. It's just extra money I've got. That's where this 12% would be actually a good investment, because if I lose, it's not the end of the world, but the average is still 12%. Any questions on standard deviation? Any questions? It's very, very important statistic. Statistics is a number that comes from the sample. Any questions? Okay, so now let's do charts. Okay, I want to look at certain charts. Some you've seen. Say yes or no if you've seen and kind of understand what a histogram is. In the chat box. You're reminded, that's fine. We're going to do a reminder anyway, but I just want to see. Yeah, so percentages of ranges, good, good. Okay. Obviously, I'm new to them because you're really struggling to hear me. But I'm trying to type a lot. So I'm going to type a histogram. So if you can't hear, you can see. There's a bar chart that is such that the x-axis is quantitative. And the bars are all of the same width. Questions on that? Okay, so for example, let me show you this guy. By the way, if you use this, here's what you do to file, make a copy, give it a name, and then click make a copy. I'm not going to make a copy because I don't need another copy, but that's what you have to do the first time you use it. Then I'm going to highlight, put the backspace so that I can get rid of the data, and now let's put in data. Maybe I'll put in the data we just had. That was 21, 18, 17. 28, 20, 18, 17. So here's a histogram. This is a histogram. Any questions? Notice what this does is it tells you between 15 and 18 years old, there were two people. 18 and 21, 3. 21 and 24, 1. 27 to 31. Any questions on this? Okay, so let me note a few things. From this, we can see we have a high bar to the left, and then it goes down. You can see the shape of the distribution. So a histogram good for showing the shape of the distribution. So words or shapes that could be skewed left, skewed right, symmetric, could be normal, and we have bell-shaped, so, or uniform. Okay, and it could be other. Who remembers what uniform, what does uniform mean? Yeah, all even probability. I like to think about it is when you wear a uniform in the military or in private school, the idea is everyone should look the same. So it's uniform if the bars are the same. Any questions on that? Is that clear? Then there's stem and leaf. So let me show you stem and leaf. If I go to stats, stem and leaf. Okay, and then you can see, I think you can see, you should be able to see this. This is a stem and leaf diagram. So what this shows you is the tens digits and the ones digit. So you can see there was a 17, another 17, an 18, an 18, a 20, a 21, and a 28. Any questions on reading and understanding the stem and leaf diagram? Any questions? Okay, so let me note the stems are the higher digits, often a tens digit, sometimes a hundreds digit. The leaves are the next digit, often the ones. So the stem and leaf we can see every data value. Right? You can't with a histogram. What are the bad things about a stem and leaf? It could be misread, so let me write down the audience has not taken statistics. Right, and passed. So that's one. Or another is if there's if there's too many data values. Imagine if there were 1 million data values, you'd have to have 1 million numbers shown, and that's not doable. Any questions on that? Okay, so the next is box plot. And for the box plot, I go stats, box plot. Like if we have literally people who were older. It's more having too many people. It's more like having 20,000 people. It's not old people. It's too many. Because you have to fit every number on a page. And with 20,000 people, there's no room. Yeah. So here's a box plot. So what a box plot does is it shows you the five important numbers, sometimes a 5-point summary. So we write this down. Shows the 5-point summary. And that is the minimum, Q1, the median, Q3, and the maximum. So notice we have our 5-point summary. Any questions on that? So the minimum was 17 years old. The box itself, see this box, this red box? The box is the middle 50% of the sample. Any questions on that? Often called the interquartile range. Okay, so it's very important in business, for example, because you want to see who are your kind of normal people, not the outliers, but just your middle group, middle 50%. Any questions on the box plot? When is a box plot not good? Multiple middle ranges, that's not a problem actually. That just means we have a wider box. Brilliant. I can copy and paste. Another values, yeah, but nothing's good with this. There's only one value, but let's write this one down. Copy, paste. Box plot is bad. When the audience is not taking past statistics. They don't have, they look at it and what the hell is that? Then the box plot is not very useful. Is that clear? Okay, so that's when the box plot's bad, is when people don't understand it. Okay, that's the big thing. It also does not show the shape of the distribution well. It's very hard to look at this and say, is this bell-shaped? Do you see that? The histogram and a stem and leaf show the shape. The box plot doesn't show the shape as well. Any questions on that? You can see a little skewness, but this is skewed right, because high side means right. That means it's a long way to get to the mean, inside the maximum. But that's a box plot. Any questions on this? Okay, I want to let you know there are others. But I only have so much time in the webinar. I try not to, make you suffer through 6 hours of lecture. But you'll get more in the book when you read it, a few others. But I wanted to give you kind of the most important ones. The histogram, the stem and leaf, and the box plot. Any questions on this? Okay, here's a question for you. Suppose my goal is to have most of the students in this class pass. Passing is 70% or higher. If the average score ends up being 74%, am I satisfied? What do you think? Okay, so let me tell you the bad news. This is a trick question. Okay, the average score is 74%. I want it to be 70% or higher, so let me show you an example. One person gets 100%, and then 73, 73, 73, 73. Wait a minute. Oh, I forgot about these guys. Let's try this again. 73, 73. Oh, sorry, not 72. That's not what I wanted. Let's start again. Apologize for this. One person gets 100. Then one gets to 69. Another one gets a 69. Another one gets a 69. Another gets a 69. Another gets a 69. What happened? Look, the average score is 74%. How many students pass this class? 1. 5 failed. Am I satisfied? Yeah, definitely wouldn't be satisfied. I don't want most of my class to fail. Okay? So it was a trick question I asked. I didn't give you enough information. Okay? On the other hand, now let's look at it with more information. What if I knew the standard deviation was 0.02%? Am I satisfied? Okay? And then we still know about the mean. If you want, we can pop this guy in. Just to remind you. So suppose my goal is to have most of the students pass 70% or higher. If the average score is 74%, and if the standard deviation is 0.02%, am I satisfied? Now the answer is yes. How come? Okay. Not one passed. So now that I do the average is 74, the standard deviation is tiny. Remember, 99.7% are within 3 standard deviations of the mean. Is that clear? So we know that 99.7% are between, well, if you take 74% and subtract 0.02 times 3, you get 73.64. And you take 74%, and you take 74%, and, sorry, not 64, 94. That's better. If you take 74% and you add 3 standard deviations, you get 74.06. Everybody passed, you see? right? Any questions on this? So knowing the standard deviation makes all the difference. You see? If everyone is really close to 74%, in other words, if the standard deviation is really small, then no one's going to get under 70. If the standard deviation is big, so in this example here, the standard deviation was 12.7%. Right? Huge. Do you see that? Any questions on this this idea here? Any questions? All right, so that brings us into what's called the z-score. So here's a formula. Z-score, the z, equals x minus, who knows how to read this letter right here? Here's a hint. Those that went to the webinar last night, someone in the on the camera was crying out with this letter. You know? If you don't, I'll read it for you. You remember that? And you remember who I'm talking about? Yeah, Salim, my cat was crying out. So you say mu. So this is, that letter is mu. Let me write down. MU is how you do it. As a cat, you do MUW, but we'll call it MU. Whereas the bottom letter, this letter here is pronounced sigma. It's Greek. Sorry about that. So that is mu. This guy is sigma. This guy is equal to the mean. And this one is equal to standard deviation. And z is x minus the mean divided by the standard deviation. Any questions on that? We call it the z-score. It tells us how many standard deviations above the mean the value is. Any questions so far? Okay. If z is greater than 2 in absolute value, so that means say negative 3 in absolute value is greater than 2, because in other words, ignore the negative sign, then we call that value an outlier. Any questions on that? If z in absolute value is greater than 3, then we call that value an extreme outlier. Any questions on that? So if I ask, is this an outlier? Find the z-score using your calculation, and then look to see, are you farther than 2 away? Yes, it's an outlier. Are you farther than 3 away? Yes, it's an extreme outlier. If you're not farther than 2 away, then if the z is not bigger than 2 in absolute value, it's not an outlier. Any questions on that? Any questions? I'm sure you've heard this word before. Okay, so here, just to note, some symbols. The sample mean is this guy, and easy to read because you say X bar. Sound good? The population mean, that was our mu. The sample standard deviation, I don't think I have to tell you how to read S. I hope I don't. And the population standard deviation, that was sigma. Any questions on these symbols? Any questions? All right, I do have something for you. The secret word for this webinar is random. So strongly recommend you write this down. Random. Make sure you take the secret word quiz, type in random, and you'll get it right. And you'll be good. So that's the secret word for this webinar. Let me just remind you what we've done. We've talked about the mean, sample means, population means, sample standard deviation, population standard deviation. We have symbols for them. The z-score tells you how far away a value is, so how rare it is to have that value. If you have a large z-score, like a z-score of 5, it is like once in a lifetime rare. If you have a z-score like negative 0.3, then you say that's common, that's normal, not unusual. Do you see how that works? So it tells you how unusual something is. Let me ask you about, we're going to use a z-score a little bit. Suppose you are taking care of an infant that was just born. With a z-score in weight of negative 3.7. Okay, and this is in the hospital side. What will happen? Do you have anyone here that's in medical, that wants to do medical, wants to be a nurse or a doctor, you know, something like that? So I usually get a group. Any of you going into healthcare? Yeah, what will happen to the child? Okay. Or in other words, even better than that is how will you, you know, how will you help the situation? Do you need to do anything to help the situation? Or is the situation fine? Yeah. So now we're talking about a z-score of negative 3.7. This is an extreme outlier. So it's an extreme outlier. On the low side, it's negative, so it's low. So it's tiny. It is very underweight. And will be in the ICU for a while. Any questions on that? Okay. Another child, another infant, had a z-score of 3.1. Okay. we'll describe the hospital reactions. Any ideas? Thoughts? So let me tell you, none of you in healthcare, maybe you don't know. By the way, my brother is he's a doctor that delivers babies for a living. So I get to talk to him about this kind of stuff. So yeah, now we have a very large baby. So probably it wasn't a natural birth, because when you have such a big baby, you need to do a C-section. Because if it's too big, it's endangering the mother to give birth in the natural way. Any questions on that? There's an example of using the Z-score. Okay, what if so let's say a third infant was born with a Z-score of negative 0.19. What can you say? Thoughts? Yeah, now it's a very normal baby in terms of birth rate, right? If there were no other issues, natural birth happened, and the baby was healthy. Any questions on this idea? Any questions? Okay. Hopefully you're getting convinced how important statistics is. So I'm pretty much said what I need to say. Just want to let you know next week our webinar is going to be on Tuesday at noon, just like this week. So that, because I know you have trouble hearing me, so let me type in what I said. So next week's webinar will be Tuesday at noon. And I want to give you a heads up. Also, I will be offline between Sunday evening and Monday night. So I want to give you a heads up on that. And sorry about that. It happens once in a while. And that has to do actually, I'll let you know, I'm Jewish, and we have it's a big holiday that we celebrate, and we do that instead. It's kind of like having Christmas, you don't work. So just to give you a heads up, if you have questions and you send me a Sunday morning question, I'll be able to answer it. But if you send a question on Sunday evening or Sunday night, you're not going to hear back from me until Tuesday, which is very unusual for me. Usually I am, get back to you right away or within a few hours. But there'll be, a day or two this quarter where that I won't be able to get back to you. I apologize for that. But any other time, I'm always happy to help you out. So I am going to stop the share, because if you notice, if you look at the agenda, Done everything we need to do. So I'm going to stop the share. I'm going to stop the